Alright, in this video we're going to go over review questions for your test, and we're going to go over just the evens, so that'll give you some opportunity to practice with some of those odds. So let's start with question number 2. The first thing we're going to do is we're going to check for GCF, and that's really what should always start out first. That's kind of at the top of the food chain, so to speak. And as we inspect it, we see that we do not have one. So we look at the fact that we have A, B, and C. A is 1. It's a trinomial, which is perfect for two binomials. So you want to check to see if 70 has any factors that'll give us the middle number, or letter B, 17. And we found 7 and 10. We simply just throw those now into two binomials, and we want to check it to make sure that it's the correct answer. It should come out to be the same thing as we started with. And it's as simple as that. Now they do get more difficult, so let's just proceed with question number 4. In question number 4, we're given two terms. With two terms, you're really only given two options from what we learned in class, and that is difference of two perfect squares and GCF. There's other options, but those were the only two that we've studied so far. And so let's just, again, start at the top, look for GCF. And the GCF is going to be n, because it's in both terms, and we can factor it out or divide it out. And again, what we want to do is we want to check it and make sure that it equals what we started with. To check, you just simply multiply that n into the binomial n minus 5. In the third one, again, we want to inspect it to see if there's any GCF. The GCF is 5, so that simply means we're going to divide 5 out of every term. When we do, we want to inspect it again, because what we have now is another trinomial, and that trinomial is one of the more easy ones because the leading coefficient in front of the n is 1. So we can take factors of 10, break it up to see if we can get it to equal 9, and the combination will be 10 and negative 1. And again, the order doesn't matter. You can throw it into your set of parentheses, or binomials, and you're done. Of course, you want to check it to make sure it is what you started with. So you're just going in forward motion now. In other words, you're multiplying your binomials, otherwise known as FOILing it, and making sure that it equals what you started with. Don't drop that 5 off either. That's a very common mistake. And it does equal what we started with. And number 8, again, I always say inspect it. Do you see something common to every term? And again, the GCF is 5. When we factor out 5, once again, it's like number 6. We want to inspect the trinomial. And since x squared is single, all we have to do is take factors of negative 30. That will add up to negative 1. They are 5 and negative 6. Again, don't drop off that 5. Okay, let's go to the next one. Not enough space to check that one, so let's go to the next set of questions. Now again, on number 10, we're only given two terms, so you only have two options. They're definitely not perfect squares, so look for GCF. And the GCF is 3x. That's what's common to both. Divide out a 3x from each term, you get 3x plus 10. And again, check it to make sure it is what you started with. Number 12. Now this is where we're getting a little bit more advanced. Again, we do want to inspect it for GCF, but as you can see, there is nothing common to any of those terms. So, as we list our ABCs, we notice that A is not equal to 4 this time. So now it's a candidate for what I call the box method. And so you simply create this box. You put the first and the last terms in the following boxes. Next, multiply the 4 with the 21 to get 84, and now you're looking for the combinations of 84 that will give you negative 19. This is where some students struggle because there's a lot of different factors of 84. So you can just start with the 4 and the 21 that you use to get the 84. You know that doesn't add up to negative 19, but you can break down your numbers and create new factors and then look for combinations. For example, I see a 12 and a 7. And 12 and 7, if I negate them, both equal negative 19. Now what I'm going to do is I'm going to put the negative 12m and the negative 7m into the box. You can see now I have an area of a box. All of those terms add up to the original. Next, you just simply take the GCF out of the top row. Each term contains a 4m. You do the same on the second row, adopting the term of the box closest to. So since the 7 is negative, then I'm going to factor out a negative 7. I'm going to do the same thing along the columns. What's common to both of those terms in 4m squared and negative 7m is just an m. It's positive because the 4m squared is positive. And again, the same thing for the second column. And you have factored it. And you just put those back into your binomials. And, of course, we want to check it. So let's distribute it or FOIL it back out and make sure we have what we started with. Number 14, as you can see, is the difference between two perfect squares. I have a perfect square on the front door and a perfect square at the back door and a minus in the middle, and there is no GCF. But you should check to see if there is one. And as noted, these are both perfect squares. The template for the perfect squares, a squared minus b squared, is a plus b, a minus b. So again, we just need to take the square roots of each of those terms, and we get 5x minus 1 and 5x plus 1. The order doesn't matter. And let's check that by distributing that out, and you'll notice this is why we always have the difference of two perfect squares, because the middle terms cancel each other out. The second one, don't be deceived. They are perfect squares as they are, but you need to always inspect it for GCF. As you can see, I can factor out a 4. It still leaves me with what appears to be the difference between two perfect squares. And so again, I can factor that into a plus b, a minus b, or 5n plus 3, 5n minus 3. And then, of course, a quick check. Don't drop that 4 off because that's a part of the answer. And as you can see, it checks. And that is going to be the conclusion of this video. I'll continue on with the other questions on the next one.